Thank you for joining this one. We are going to look at the Einstein's equations of photoemission, whereby we're going to analyze them graphically. So, trying to relate the equation, we know that energy is first of all given by hf, whereby h is the Planck's constant and f is the frequency of the radiation causing photoemission. So we can say that this energy is usually splitted in the work function, and work function of metal is given by hf naught plus the kinetic energy, which is given by half mv squared. For this case, we have the maximum at which the electrons will move at. Now that we know that it is given by this, we can again say that according to the work energy, then work energy theorem relates EV to half mv squared. The stopping potential times the charge of an electron should give us the kinetic energy of the electrons. So this means instead of half mv squared, we can have hf being equal to hf naught plus EVS. And with this we can have EVS on one side, then on the other side we shall have HF minus HF naught when we take it to the other side. We can first of all divide it through by E. So that's VS equals to HF divided by E minus HF naught divided by E. So now, in case stopping potential is plotted against frequency, such that we have frequency in hertz on this side and stopping potential in volts on this side, then we shall obtain a graph having this shape. And to a graph, we usually say this, that according to this equation, we can see that because this one is in the y-axis and f is on the x-axis, then the coefficient of f, which is h out of e, is provided by the slope. Therefore, from such a graph, slope is going to give us h out of e, because h out of e is the coefficient of whatever quantity is in the x-axis, and mathematically that coefficient should give us slope. Therefore, because slope can be obtained from the graph, then we can say Planck's constant then will be given by slope times E. And E is a constant which will be provided in the question. Again, because we can see the negative HF, then this one is the constant part according to the equation of a straight line, and we can say this constant is given by the y-intercept. And according to the nature of the graph, the y-intercept is going to be a certain. When we say negative HF naught equals to negative a given value here, then the negatives will cancel out, and we can argue that the y-intercept is going to give us HF naught out of E. The y-intercept will give us HF naught out of E. That means the work function, which is HF naught, can again be given by y-intercept times E. Y-intercept times E. And finally, we can interpret the x-intercept now, the x-intercept, whereby we should argue that the x-intercept, because we have v in the y-axis, then at the x-axis, potential is going to be 0. And because stopping potential is going to be 0, then we can now equate at the x-intercept. At the x-intercept, we are arguing that Vs equals to 0. So we can say 0 equals to hf divided by E minus hf naught divided by E again. Therefore, with this, we can now bring hf naught E to this side such that hf divided by E equals to hf naught out of E. And with this now, we can have h out of E cancelling will be equal to frequency naught. Which means, from this graph, the x-intercept is going to give us the threshold frequency of the given metal. So thank you for following. Kindly subscribe to this channel and share the link.